So for chapter 7, we're going to start off not too bad. We're going to look at solving systems of both linear and nonlinear equations. So instead of just ax plus by equals c and a couple of equations there, we're going to look at ones where you have quadratics and cubics and things as well. Okay? So first off, well, substitution. This is that substitution, elimination, solved by graphing, that kind of stuff. So the first two sections people should be very comfortable with. So the idea is if I have the two equations, I'm going to solve one for the other variable, plug it in, and work from there. Now some of the methods we'll look at in these first three sections are solving by substituting variables, solving by graphing, solving by elimination, and solving by what's called Gaussian elimination. Now Gaussian elimination has to do with matrices. Okay? Well, actually, we'll do it without matrices to start, though. Substitution, this goes through the step-by-step, honestly. You should be comfortable with substitution by now. Solve for one variable, substitute into the other equation, solve the equation, back substitute your answer into the first equation, and then check your answers. Make sure you didn't screw anything up. Okay? So, if I have an equation like this, well, if I want to solve by substitution, what would I do? Yeah. Literally move the y to the other side, then substitute for what? Yeah, it doesn't honestly matter. If I want to replace this y, replace it with what it's equal to. So I have 5x minus 3x equals 6. And if x is 3, what's y? 3. Plug it back into the original. This one's a very, very simple example. Typically list your answer as an ordered pair. Okay. Now, you also have, though, they're not all going to be like that, obviously. That wouldn't be on a test. You will have word problems where you need to come up with the equations on your own. Okay. So, a total of 25 grand is invested in two funds, paying 7% and 4% simple interest. The yearly interest rate is 14.05, or yearly interest return, I should say. How much is invested at each of those rates? So, if I want to write some equations for this, where would I start?
X plus y equals 25,000.
Yeah, x plus y equals 25 grand. Then what? 0.07x plus 0.04y equals your interest. Then what? Substitution. So, yeah, if you move the y over, then I'm going to replace what x is equal to. 0.07 times your 25,000 minus y. 0.04y is 14.05. What do you get when you distribute the 0.07? Move the decimal a couple times, you get 7 times 250, so that's what, 1750? Yeah? Okay. Then what? Combine your y's. I would also be lazy and I would subtract 1750 at the same time. Combine those together, make negative 0.03y is equal to, what is that, negative 345? Yeah. Then divide by your negative 0.03. Gives you y is equal to what?
Negative 11,000.
I owe money?
Never mind.
Negative divided by a negative. So then what's your other answer? 13,500. So then what's my actual answers? What's the difference between the 13,500 and the 11,500?
The rates.
The rates. 13,500 is at what interest rate? It's the x, so it's the 0.07, so it's at the 7%. And the 11,500 is at your 4%. It makes you actually answer the questions on word problems. Because you would miss points if you just said x is equal to that, y is equal to that, and done. Questions? Okay. Now, this one isn't a system of linear equations, it's just a system of equations, because one of them is what shape? Parabola. It is a quadratic, it is a parabola, though, because it's y equals x squared once you do some manipulation. But, for this, if I want to solve it by substitution, what would you do first? Yeah, y equals 2x plus 5. And then plug that in for your y value. So I have x squared plus 3x minus 2x plus 5 is equal to 1. Why? Yeah, it's minus everything that y is. So technically this is in parentheses. So the negatives...
After you're done with the equation.
I only got like 3 more lines first hour, so you guys noticed right away. So the negative, I want to distribute it. So when I combine these together, I'm going to get x squared. 3x minus 2x is just plus x. Negative 5 equals 1. So then what? Subtract the 1s, get it, and then factor. Yep. So that'll factor into what? Minus 3 plus 2? Plus 3 minus 2. There we go. So then your solutions for this are x is equal to, and x is equal to 2. Now, am I done? I have to plug both of them back into the other equation here. So I'm going to have y equals 2 times negative 3 plus the 5, and y equals 2 times 2 plus the 5. Negative what?
Negative 2 times.
No. I'm doing this equation. I mean, yeah, if you plugged it in here, it'd be negative 2 times that. Yeah, I plugged it into this one. But, yeah. So what's that going to give me? Negative 1 and 9. So my actual answers then are what? And 2, 9. So those are your two answers. Okay? Your turn. Go ahead and solve this one. So, for this, once you actually do this all out, y equals 2x plus 3, plug it in, square it, subtract it, you get all negatives equals 0. And you can always flip all the signs. From that point, you want to look at the discriminant. So b squared minus 4ac. Yeah, wasn't sounding right in my head. When you do that, you're going to get 64 minus 4 times 2 is 8 times 9 is 72. Because you get a negative number under here, means your solutions would not be real. Therefore, this thing has what for solutions? No solutions. And that can't happen. Now, graphically, what does that mean? There are no solutions to a system of equations. They never intersect each other. Now, what do these two graphs, what shapes are these? That's a line there. This isn't a parabola, though, because the y is squared. And the x is squared. Yeah, it's be a hyperbola. Because the y squared is negative, the x squared is positive, it's going to be a hyperbola. Because they have no real solutions means they will never cross each other. So that line's just kind of splitting right between the two parabola-looking parts of a hyperbola. And graphically, that's what's going on. You can often have two solutions, one solution, or no solutions for systems. Now, if you're talking specifically about two lines, a linear system, then you can either have one solution, no solutions, or what? infinite solutions where they're literally the same line. Okay. Now, but you can't have, just like the last one, you can have hyperbolas mixed with lines, parabolas mixed with lines, things like that. And you may easily have 1, 2, or no solutions there. So if I have these two lines, go ahead and graph these two and find your solutions on the calculator. Or you graph them without the calculator, if you like. So, where do they intersect?
2, 9.
2, 9. Okay. But, like I said, some of these equations, you're kind of used to doing this. You've been doing this since at a basic form, Algebra 1, at least Advanced Algebra, Algebra 2. So they are going to throw quite a few word problems at you as well. Now, some of these word problems, just to get some of the terminology down, most people should be comfortable with this, but just to make sure we're all on the same page. If you're looking at cost of producing things, it's always going to be made up of two things: your initial cost for the setup and your unit cost for actual production run. Those two added together give you your total cost. Revenue is just cost, or wait, make sure I say that right. It's just whatever the sales are times the number of units moved. When they're equal to each other, that's what's called the break-even point. Well, it's just the intersection of the two lines. Okay? So, if I have this problem, I'm going to set up those two types of equations. I'm going to set up a cost equation and a revenue equation. Now, the revenue is usually the easiest one to write. What's the revenue equation in this case? Say again?
You gotta find out, maybe like 12x or something.
What, 12?
Find if it's 35.2 minus 20.
Oh, you're getting ahead of me a little bit. Revenue equation is all I'm looking for here. Revenue is easier than that. You're thinking profit.
Alright.
Revenue is just how much money's coming in, not how much doesn't take into account money going out. So this is 35.2 just times x. Okay? Your cost is going to be what for that equation? 6,000, then what? Would be plus. Because the idea is this is how much total cost there is to produce those things. Okay? So it's going to be 6,000 basically to get all the machines ready to run is $6,000. Then to actually stamp out whatever the product is, the amount of materials and the amount of labor going into making each one of those products is $2,320 each. Okay? So then, to find the actual break-even point, what do I do with these two? Set them equal to each other and solve. So I have 6,000 plus 23.2 x is equal to the 35.2x. Then what? Subtract, and that's where you were getting the 12x from. So then what's 6,000 divided by 12? 500. So the idea is that 500 is your answer. That's what you need to actually be able to break even. So 500, what would your label be? Units. Okay. Questions on that one? One more. From 2001 to 08, the population of City A was increasing at a faster rate than the population of City B. Models that approximate the two populations in thousands are given there. where T represents the number of years since 2001. According to these two models, when would you expect the populations of these two cities to be equal? Well, conveniently, they already give them to you. P equals both equations, so what would I do? Set them equal and solve. So 4947.3 and 95T. So move things around a bit. What's your next line going to look like here? Actually, just go ahead and solve it. Figure out what T is. What do you get for T? What'd you get? 3.18. So what's my answer? So sometime during 2004. Because 3.18 years since 01. Questions on any of it? Okay. Rest of the time is yours.